Our hypothesis is that mechanical engineering will be more able to attract and retain a diverse community of students without making compromises on technical rigor if we have greater linkages between the fundamentals and applications, if we have more linkages between technical and non-technical material, if we have more teaming experience, and that is a pedagogical issue, if we have shorter critical path lengths so that the student who didn't know they were interested in engineering until they were a sophomore could finish without tremendous financial burden, needing an extra 2 years or a year of college. If there is more focus on the impact of engineering on the human experience, and if we promote a general atmosphere of inclusivity rather than exclusivity. And I particularly like to hammer on that last point after ABET because it's the inverse of the ABET model. The ABET model says that you can't call yourself an engineer if you didn't graduate from an accredited program, and accreditation will be exclusive. What we're saying is that we think it's important instead to focus on inclusivity. Our team, I told you we had 8 institutions. Cal State LA is a Hispanic serving institution. Howard and Tuskegee are both historically black colleges. Smith is the first women's school in the country with an engineering program. Michigan State University and the University of Washington are, of course, big public institutions. Stevens, a technological institution, and Hopkins, a relatively small private institution. So we really span a whole lot of different kinds of institutions. We also have an assessment team. Pat Campbell will be talking today, but Susan Metz and Suzanne Brainerd have also been involved with us. Now, our research protocol has been to take the curriculum that exists now, to divide it into topics at about the level of a syllabus, to evaluate those topics, and then generate a map of what the curriculum looks like. From there, and those are all done, what we have done and what we are now working on is then taking that, with each topic we are associating material, what are the real prerequisites, what are successor topics, and we use that to try to then create an optimization problem that we can solve to assemble a completely new curriculum from the ground up. The last piece, and the piece that's currently ongoing, is pilot testing this. So some of the unique characteristics of what we've been doing, first of all, we're focusing on the curriculum. And again, I want to say we're not telling you that pedagogy doesn't matter. It is critical. But what we're saying is that our focus for this project really is more on content. We are looking at the entire curriculum at once. Some people think we're nuts, but we think it's the only way to do it. And we are using engineering methods to study the curriculum. So let me go through some of the pieces now and tell you some of the results and where we are. We took all of our team institutions, so that was 8 institutions, and we added MIT because of their open courseware program. So that meant all of their syllabi were on the web and easily accessible. We broke those down, all of the required courses, into topics, and we found ourselves with roughly 2,150 topics. We alphabetized them all, and the reason we did this is once you get topics dissociated from a course, it's easier to talk about, do students need to have that very specific topic in order to graduate and call themselves a mechanical engineer? That's different from saying, do all students need to have fluid mechanics, where everybody immediately says, you bet, okay? We edited the list to combine duplicates to eliminate unnecessary topics, and that got us down below 1,000. We then added topics we think needed to be there in the future, several biologically favored topics, and that got us back to about 1,000. There were all sorts of challenges, not least of which was terminology. It took me, I confess, 6 months to figure out that anti-differentiation was the same as integration. I had never heard it called anti-differentiation. So, you know, there were things we had to do, but the nice thing with this is then we could look at the frequency information, we could look at how often topics occurred in those 9 different institutions, and we found that if you define the body of knowledge as being those topics that the majority of those 9 institutions think should be there, you only get 70 topics. So that tells us a lot of things. It tells us that institutions are more different than you would guess, just looking at course titles. Everybody teaches the same course titles. We're really much more different than that. And that if the body of knowledge that is core, that everyone must see, is really small, then there's no reason why one couldn't theoretically craft a 4-year degree program. It's not a pipe dream. We have taken this, we've taken the topics, and for each we've listed prerequisites for understanding, successor topics, applications to which they might relate, and we're really aiming for applications that have broad appeal. We have looked at non-technical material which could be linked to them, and the number of hours we think you need to dedicate to that topic in the curriculum. So that gives us a database, and we are now using a variety of optimization techniques to use this to develop clusters that we could then call courses. I can tell you that in one approach that has been used, Tom Kibler, using genetic algorithms, has come up now with a series of clusters, each of which is completely different from any of the courses we currently teach, and mixes things up. So that's actually really reassuring. We have been doing a fair amount of work on new applications, and Ian will be talking about that, so let me simply say we intentionally looked at 3 courses: the freshman level design or graphics course, the sophomore mechanics of solids class, and the junior fluid mechanics class. And we've been piloting those new applications to determine the impact of changing the application flavor. And Pat will show you some of those results. And what we have still to do is expand those new applications to other core mechanical engineering courses, and you will be helping us do that today. We also want to make all of this available online. We need to generate that totally new curriculum structure from the database and start piloting those new courses and modules. So that very quickly is where we are headed with this program.